Hello wonderful person, this is Anton, and in this video we're going to be discussing yet another significant milestone in astrophysics. And that's because for many decades researchers have been trying to find some kind of evidence for the existence of some of the first stars in the universe. Or basically the very first generation of stars that had to have formed millions of years following the Big Bang. Stars that essentially shaped the universe as we know it. But for the most part, their existence and basically everything about these stars was more or less theoretical. In other words, everything about these stars was mostly based on various mathematical and physical models and not actual observations from various telescopes. But that's maybe until now, because based on a series of studies that just came out, and specifically studies focusing on this now famous galaxy referred to as GNZ11, has now provided scientists with some of the most compelling evidence that this galaxy seems to contain these stars, and there's quite a lot of them in here. And so in this video we're going to discuss exactly what scientists think they discovered, why this is important, and obviously what we know so far. But first, before we start, let's discuss exactly how scientists classify stars, because in this case the naming convention is a little bit confusing. And well, here, these first stars are normally referred to as population 3 stars, which is already kind of backwards. In other words, astronomers use a slightly confusing system of populations in order to describe the generations of stars. Now, stars like our Sun and a lot of other nearby stars that are relatively young are known as the population 1 stars. And normally these stars are the youngest because they contain a variety of different heavier elements inside the star itself. And in this case, in astronomy, anything that's not hydrogen and not helium is usually referred to as metals. So these are basically high in metals stars. And while most of the stars known to us are actually population 1 stars, but some are also population 2 stars. These are much older stars and are very metal poor and are normally over 10 billion years in age. And so in this case, population 2 stars seem to be stars that were formed from the leftovers from some of the first supernova and from some of the more primordial material that used to exist. In other words, if it took maybe 1 or 2 supernova to create population 2 stars, stars like our Sun very likely involved tens if not hundreds of supernova in order to reach the right level of metallic enrichment. But the holy grail has always been population 3 stars, or basically first stars. The stars that existed before any supernova happened, and the stars that eventually resulted in some of the first metallic material. And so basically here we're talking about the first generation of stars formed directly from the primordial gas following the Big Bang. And so that's the only type of stars astronomers have never seen anywhere. As a matter of fact, not so long ago, scientists discovered a somewhat bizarre population 2 star referred to as Pig 2503. And this star had very unique chemical composition with some of the lowest iron abundance ever seen. It contained almost 100,000 times less calcium and iron compared to our Sun. And that of course implied that this particular star, that was approximately 150,000 light years away from the Sun, seemed to have formed right after the initial explosion from some kind of a first generation star or the population 3 star. In other words, this was a very interesting discovery of the second generation star that formed from some of this first material, which also would make this possibly one of the oldest stars near us. But despite this discovery, we still have no idea what the first stars were like. In other words, we have no idea if they were very large and only lived for a very short time, or if they were supermassive or possibly even overmassive, resembling these enormous objects, possibly thousands of solar masses in mass, that would eventually just collapse directly into a black hole, only leaving some leftovers behind. Which is basically why astronomers wanted to find an actual sign of them in some kind of a distant galaxy. But it was pretty clear that these stars seem to be kind of elusive, because none of the telescopes so far found anything resembling any definitive evidence. And so researchers started to assume that they must have burned through their fuel in a very short time and very likely disappeared very quickly. But then, a few years back, researchers discovered GNZ11. This was actually originally discovered by the Hubble Space Telescope and eventually reanalyzed by the James Webb. And so here we have a galaxy that existed 400 million years following the Big Bang, and essentially existed during the so-called cosmic dark ages. But in some of the recent studies, while studying the environment around this galaxy, researchers discovered something they now gave a proper name. They essentially called it Hebe, or possibly Hebe. This was reported in the studies you can find in the description, and it essentially represents a somewhat unusual region. The region you can kind of see right here, so it's not exactly inside the galaxy, but seems to be very close to it. And it's this particular region that now seems to be super exciting for one simple reason. It seems to contain very specific signs that are very often attributed to population 3 stars. And so let's discuss exactly what this means and what researchers believe is being produced here. And so here researchers used high-resolution spectroscopy from the JWST and discovered very strong helium-2 emission lines that seem to not contain any metal lines. Or I guess in plain English, they discovered gas being ionized or being energized by something extremely hot, very likely at least 100,000 degrees Kelvin or possibly even higher. And this seems to be in a region where no heavy elements like carbon or nitrogen could be detected. And in current astronomical models, the only objects capable of producing this are believed to be population 3 stars. In other words, because it seems to contain no metals and it seems to be something extremely hot, it will be very difficult to explain this as something other than the first generation of stars in the universe. But this wasn't just some kind of a first hint or some kind of a first unofficial detection. Here they managed to confirm this with additional observations. A companion study detected what's known as H-gamma or ionized hydrogen in the exactly same location as before, and this proved that the source seems to be real and not just some kind of a fluke in the data. And the light coming from here seems to have two specific components, the C1 and C2. They seem to be separated by about 120 km per second, which basically suggests that C1 is likely the pure population 3 system, and C2 might be slightly more polluted and might involve some of the first supernova. In other words, this suggests some kind of a cluster of population 3 stars surrounded by the gas region where some of the stars already exploded and possibly started to create population 2 stars, which by itself presents us with the strongest evidence to date for the existence of these elusive objects. But obviously here we cannot see individual stars. Because of the distances involved and because this galaxy, the whole galaxy, is basically just a few pixels in size, here we can only deduce some of this information by observing the emissions and the types of radiation produced from this object, and by then comparing this to some of the predictive models. But, assuming this is correct, why exactly is this important? Well, for one, this allows us to test the initial mass function, basically the recipe universe used to create some of these first stars. And so here the data from Hebe suggests that these stars weren't just big, they seem to be top-heavy. Or basically the universe prefers to make massive stars over smaller ones, at least in the beginning. And this is also crucial because it sort of hints at why the universe was able to transform so quickly and reionized or basically became transparent in such a short period of time. And it also explains why we don't really see any metal-free stars in the Milky Way. Many of these stars are just a little bit too big to survive so long and exploded billions of years ago. Although obviously stars like this, the star from the dwarf galaxy Pictor, seems to show us where a lot of the material from these stars eventually ended up. This was formed directly from the guts of population 3 supernova. But naturally, in order to confirm this, astronomers first have to rule out any possible additional explanation. Or basically they have to make sure that this is not something else, like for example, some kind of a primordial black hole, or some very bizarre star cluster involving supermassive stars. And so for example, could this actually be a black hole? Well, we know that GNZ11, the nearby galaxy, does have a black hole, but the calculations right now show that photoionization from the black hole cannot explain all of the light coming from this region. As a matter of fact, it seems to be way brighter than a black hole should produce. Alternatively, this can also be what's known as Wolf-Rayet stars. These are stars that exist today as well and are normally extremely hot and very often super luminous. These are actually some of the brightest stars in the Milky Way today. But we know that all of these stars, all of these Wolf-Rayet stars, always show metal lines, or basically, they always have some additional emissions involving other stuff like for example calcium, carbon, and even silicon, that this particular object, Hebe, does not seem to show at all. In other words, here we have something just as hot and just as luminous, but without any metallic stuff. And so here the implications right now are quite profound. Basically, once again, if confirmed, and right now this is actually extremely close to being the first official confirmation, this represents the first direct look at the cosmic dawn, or the end of the Dark Ages, the transformation in the universe when it finally started to become brighter and more transparent. At the same time, this obviously also confirms a lot of different models we have about star formation, while technically also accomplishing one of the main missions for the James Webb Space Telescope, and that's because one of its missions was to find these stars. And this also tells us that some of these first stars, or possibly all of these first stars, very likely formed in massive clusters. So basically they were not just born by themselves, they seem to have formed extremely quickly inside very massive deposits of primordial gas. And they were also the primary engines that transformed the dark cold universe into the beautiful universe we observe around us today. So essentially this is how the entire universe as we know it started. And honestly, this is really the science at its best. Here essentially we have some kind of a theoretical prediction from decades ago and the data from one of the recent telescopes to finally confirm it. And specifically confirm it using the tool specifically designed to find these stars. But naturally, this is not really the end. There is still so much to learn about all of this, and there is still so much to discover. As a matter of fact, we know nothing about their mass, we know nothing about their age or how long they survived, or of course, what's inside of them. But for now, this region, referred to as Hebe, or possibly Hebe, stands as the most compelling candidate for the existence of these first stars. But at least for now, that's all I wanted to mention. Unfortunately, we're not going to know much more until additional studies, or until another such region is discovered somewhere else. And so that means that we'll definitely come back and discuss this more once there's some additional data. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.